Hello everyone, this is a video on concavity and point of inflation. When we talk about concavity, we are talking about the shape of the graph. If it looks like this, it's concave up, and then when it looks like that, it's concave down. So with cubic graphs, you'll usually have these two shapes together. You'll find that you have a graph that looks like that. Right? Do you see from here to there, the graph is concave down, and when you start there going that way, the graph is concave up. So this point where it's where the point where it starts being concave down then concave up, this is called the point of inflection. That's the point of inflection. So I'm going to show you how you calculate the concavity, concave up, concave down, and point of inflection. When we have a function, like here we have this function, when then we want to find where the graph is concave up, we do the second derivative. When you have two dots like that, you do the first derivative and do the second derivative. Then you take that second derivative, you say it's greater than 0, and then you solve for x. Then you get x values where the graph is concave up, and then second derivative less than 0, you'll find concave down, and then second derivative equals to 0, you find point of inflation. Then that x value that you get, you put it in the original equation, then you'll find the y coordinate of the point of inflation. Okay, let's look at an example. Right, our function is f at x is equals to x cubed minus 6x squared plus 9x minus 4. They say find the point of inflection, number 1. So I'm going to do the first derivative using the power rule. So I'll have 3x squared minus 12x plus 9. The derivative of the constant is 0. This is the first derivative. Then the second derivative, you derive the derivative. 3 times 2, 6x minus 12. This is my second derivative. So they say I must find the point of inflection. So I'm going to have 6x minus 12. I'm going to equate it to 0, then solve for x. X is equals to 2. So at this point, that's your point of inflation. But now I need a coordinate. I'm going to take this point and put it in the original equation to get the y coordinate of the point of inflation. Let's do that. Now to find the x coordinate, the y coordinate of the point of inflation, f at 2, I put it in the original equation, not in the derivatives. So I'll have 2 cubed minus 6, 2 squared plus 9, 2 minus 4. Then let's punch it in our calculator. So the coordinate of point of inflation is 2 and minus 2. Now number 2, they say for which values of x is the graph concave up. So you remember when you say concave up, concave down. For concave down is the second derivative, you say less than 0. So we've already calculated the second derivative, 6x minus 12, then you say less than 0 because it's concave down. Then 6x less than 12 divided by 6, then x is less than 2. All the values where x is less than 2, the graph will be concave down. Okay, this is the end of our lesson. Thank you for watching.